Hello everyone and welcome back to part 4 of our tutorial on building a viral Telegram game. In our last session, we successfully configured our backend, set up the database schema, and established a fully functional local development environment with ngrok. Today we are shifting our focus to the front end. We'll build the essential providers, utility functions, and the core UI components for our app's main screen. We'll start by creating a React provider for our Ton wallet connection. In the Components folder, I'll create a new subfolder called Providers, and inside it a file named tonprovider.tsx. Let's look at this component. We are using a dynamic import from Next.js to load the Ton Connect UI provider. This is a crucial optimization. Wallet connection libraries are client-side only. They interact with browser APIs that don't exist in the server environment. Dynamic import with SSR false ensures that this component is never rendered on the server, preventing errors. Inside the provider, we configure it with our manifest URL. This manifest is a simple JSON file that describes our app to Ton wallet, showing its name and icon. We also configure the TWA return URL to point back to our Telegram bot, ensuring a smooth experience for users returning to the app after connecting their wallet. Now let's integrate this provider and set up our application's global styles and fonts. I am opening the root app/layout.tsx file. I am replacing the boilerplate with our custom layout. Let's break it down. First, we import two fonts from Next Font Google, Freedoka for our main UI text and Chua for the large stylized points display. Next, we export metadata and viewport objects. The viewport configuration is especially important for Telegram mini apps. We set user scalable to false to prevent users from accidentally zooming in, and viewport fit to cover to ensure our app uses the entire screen on devices with notches. Finally, in the root layout component, we wrap the children with our new Ton provider. By doing this at the highest level, we make Ton Connect features and hooks available to every single component in our application. With the layout in place, let's create a few essential utility functions that we'll use across our front end. Inside the lib folder, I'll create a new utils directory. The first file is format.ts. This is a straightforward helper file containing functions to format numbers with commas and format dates, keeping our UI consistent. Next, I'll create Telegram web app.ts. This file provides safe client-side functions to access the Telegram web app SDK. The get Telegram init data function is the most important one here. It reliably retrieves the user's init data string, which is our key to authenticating the user with our backend. Now for a really important one, API client.ts. This will be our centralized client for making authenticated requests to our own backend API. This API client class uses a singleton pattern, meaning we only ever have one instance of it. Its core is the authenticated request method. Before sending any requests, it calls our get Telegram init data utility and automatically attaches the init data string to the request headers as x Telegram init data. Our backend will use this header to validate every single request. This is fantastic, because it means we never have to worry about authentication when calling our API from any component. The client handles it for us. Alright, with our utilities ready, it's time to build the three main interactive components for our home screen. I'll create them inside the components folder. First up is userinfo.tsx. This component will be the main dashboard for our player. This is a stateful component that does a lot. It receives the user data and current points as props. It uses our helper functions from gameconfig.ts to calculate the user's current level and their progress toward the next one. The most complex part is fetching the user's global rank. We use a useEffect hook to call our /API/leaderboard endpoint. To prevent spamming our API every time the user's score changes slightly, the request is debounced. This means it waits for a couple of seconds after the last point change before fetching the new rank. It also includes a robust retry mechanism in case the network request fails. The JSX part renders the user's level icon, their name, the dynamic level progress bar, and their key stats, level rank, and referrals. Finally, it displays the large stylized point count using the custom Jua font and our points display CSS class. Next, I'll create the daily bonus.tsx component. This component manages the daily reward system. Unmount the check claim status function makes a GET request to our /API/points/claim daily endpoint to see if a bonus is available. If the bonus is not available, a useEffect hook starts a countdown timer, showing the user exactly when they can claim their next reward. The Handle Claim button makes a post request to the same endpoint. If successful, it calls the onClaim function to update the user's points in the main UI and shows a success toast. The final component for this section is playbutton.tsx. This component is very similar in structure to the daily bonus. It uses a useEffect hook to periodically call the /API/game/check-availability endpoint. If the user is on a 3-hour cooldown, it displays a cooldown timer directly on the button. The most important function is Start Game. When the user clicks play, this function makes a post request to /API/game/start. The backend creates a secure game session and returns a unique session ID. We then save this ID to the browser's session storage and use the Next.js router to navigate the user to the game page, officially starting the game. And with that, we've built all the individual pieces for our main screen: the data providers, the utility functions, and the core interactive UI components. In our next video, we'll assemble all of these components on our main page, handle user authentication on the client side, and bring the home screen to life. Thank you for watching, and I'll see you in the next part.